This is SpaceTime Series 24, Episode 58. Coming up on SpaceTime, evidence of recent volcanic activity on Mars. China lands a rover on the Red Planet. And Rocket Lab blames engine problems for the failure of its latest Electron mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims there's evidence of recent volcanic activity on the red planet Mars, with images showing eruptions that could have taken place within the past 50,000 years, which is pretty much the present day in geological time. The findings, reported in the journal Icarus, are based on satellite observations showing geologically recent explosive volcanism in the Elysium Planitia region, which would be the youngest known volcanic eruption on Mars. Most volcanism on the red planet is thought to have occurred between 3 and 4.6 billion years ago, with some smaller eruptions in isolated locations continuing perhaps as recently as 3 million years ago. But until now, there's been no evidence to indicate whether Mars could still be volcanically active today. The new study's lead author, David Horvath from the Planetary Science Institute, says new images show a mysterious dark deposit covering an area slightly larger than a city. He says it has a high thermal inertia. It includes high calcium pyroxene-rich material and is distributed symmetrically around a segment of the Cerberus Fossae fissure system on the Elysium Planitia, all typical of aeolian or wind-driven deposits. Horvath says the feature looks similar to dark deposits on the Moon and Mercury, suggested to be explosive volcanic eruptions. He says it may well be the youngest volcanic deposit yet documented on the red planet. While there are numerous examples of explosive volcanism on Mars, the majority of the red planet's volcanism consists of lava flowing across the surface. However, this Elysium Planitia deposit appears to be very different. The new feature overlies the surrounding lava flows, and appears to be a relatively fresh deposit of ash and rock, representing a different style and time period of eruption compared to previously identified pyroclastic features. He estimates the eruption could have spewed ash as high as 10 kilometres into the Martian atmosphere. Horvath says Elysium Planitia hosts some of the youngest volcanism on Mars, dating to around 3 million years ago, so it's not really entirely unexpected. He says it's possible that these sorts of deposits were more common but have been eroded or buried. The site of the eruption is about 1,600 kilometres from NASA's Mars InSight lander, which has been studying tectonic activity on the red planet since its arrival in 2018. 2 Mars quakes identified by InSight have been localised to the region around Cerberus Fossae, and recent work has suggested the possibility that these could well be due to the movement of magma at depth. But it's the apparent young age of this deposit which absolutely raises the possibility that there could still be volcanic activity on Mars. And so it's intriguing that recent Mars quakes detected by the InSight mission have been sourced to the same region. However, sustaining magma near the surface of Mars so late in Martian history with no associated lava flows would be difficult. And so that suggests a deeper magmatic source would probably have been needed to create this eruption. Horvath says a volcanic deposit such as this also raises the possibility for habitable conditions near the surface of Mars in recent history. The interaction of ascending magma and the icy substrate in this region could have provided favourable conditions for microbial life fairly recently, if such life ever existed on Mars. And so it raises the possibility of existent life in this region. It's a fascinating possibility. This is SpaceTime. Still to come. Red China lands a rover on the red planet, and Rocket Lab has blamed the possible engine problem for the failure of its latest Electron mission. All that and much more still to come on SpaceTime. Following in the wake of America's latest success with its Mars Perseverance rover and Ingenuity helicopter, which have now commenced operations on the surface of the red planet's Jezero Crater, China has landed its own rover on Mars. The lander was deployed from the Tianwen-1 spacecraft, which has been orbiting Mars since February following a 6.5-month journey from Earth. Mission managers spent several months scanning the red planet's surface from orbit looking for a suitable landing site. Once they spotted a region meeting all their conditions, they released the lander and its attached rover, which entered the thin Martian atmosphere at an altitude of 125 kilometers, using both parachutes and then retro-rockets to descend down to the surface. Once safely on the ground in the vast Utopia Planitia lava plain in the Martian Northern Hemisphere, the 240-kilogram Zhurong rover successfully rolled off its lander for what's expected to be a 3-month mission. Zhurong is named after a mythical Chinese fire god. The 6-wheeled solar-powered rover's design is a scaled-down copy of NASA's highly successful Spirit and Opportunity rovers, which landed on opposite sides of Mars in early 2004 and continued operating for years beyond their planned 90-day mission profiles. Zhurong's science suite includes a ground-penetrating radar, a laser spectrograph, an infrared spectrograph, a multispectrum camera, meteorological sensors to monitor atmospheric temperature, wind speed and air pressure, and a surface magnetic field detector. The successful touchdown is considered a major milestone in China's ambitious space program. This is SpaceTime. Still to come, Rocket Lab blames an engine problem for the failure of its latest Electron mission, and scientists at the ANU develop nanothin radiation shielding. All that and more still to come on SpaceTime. Rocket Lab has blamed engine problem for the failure of its latest Electron mission. The problem occurred during the ignition of the second stage of the Running Out of Toes mission, the 20th flight for the company and the second failure in the past year. The mission from Rocket Lab's Mahia Peninsula Launch Complex on New Zealand's North Island east coast was carrying 2 Black Sky Global Earth Observation satellites into a 430-kilometre high orbit. The Earth observation satellites would have been the 8th and 9th for Black Sky, providing monitoring of shipping and climate observations.
My name is Muriel Baker and I'm here at Rocket Lab's Mission Control Centre in Auckland, New Zealand. This mission has a window of approximately 2 hours and we're expecting to launch right at the top of that window at 10:08 p.m. New Zealand local time. Electron is fueled and ready for liftoff from Rocket Lab's Pad A. Our launch operations team are not working any issues, and with greens across the board, we're well set for an on-time launch. Running Out of Toes is a significant mission for the team here at Rocket Lab as our next major recovery test. For only the second time ever, we will attempt to bring Electron's first stage back to Earth under a parachute and splash it down gently in the ocean as part of our efforts to make Electron the world's first reusable small launch vehicle. Our recovery team is currently stationed in the Pacific Ocean, waiting for Electron splashdown so they can retrieve it and bring it back to our factory for inspection. However, weather conditions have deteriorated significantly in the splashdown zone, which means we have limited live communications with the recovery team. Visibility at sea is also greatly reduced, so it may take some time to provide confirmation of a successful splashdown. Nonetheless, conditions are optimal for launch, so we are proceeding with the count.
All stations, LD and mission, proceeding with a go-no-go sequence at this time. Looking for your status to proceed for launch. Stage.
Status go.
Avionics.
Avionics is go.
Running Out of Toes is our third mission for 2021 and the first of several dedicated launches this year for Black Sky, which provides geospatial intelligence and global monitoring services through their low Earth orbit constellation. Electron will be launching 2 of these satellites at a 50-degree inclination. Tonight's launch will be the 20th time Electron leaves the pad, powered by our 200th Rutherford engine. It's incredible to think that we've built, tested and fired 200 of our unique 3D printed electric pump-fed engines. Rutherford is the world's first 3D printed orbital rocket engine, a unique design that went against the grain of traditional rocket propulsion systems when we first introduced the idea. Rutherford also made space travel electric by replacing the traditional gas generator cycle with electric pumps powered by lithium polymer batteries. A check-in on how we're tracking to liftoff. The team are working no issues with the launch vehicle. Electron's payload remains healthy and the weather is looking clear for an on-time launch. In T-2 minutes, the autonomous flight computers on Electron will take over the count. At around T-minus 1 minute 30 seconds, we should hear the call that LOX loading is complete on Electron. And then shortly after that, we can expect confirmation that the launch vehicle's first and second stages are pressurized for launch, followed by the 10-second countdown to liftoff with engine ignition at T-minus 3 seconds.
HV blips are nominal.
Confirm LDs go for launch.
Hold.
Got to hold. Recycling T-minus 12 minutes. GC confirm a launch inhibit mode.
Still in prime mode. Confirmed.
We're in inhibit at this time.
So you heard it there from Mission Control in Auckland. Right now, Electron has entered a hold. We are still sitting tight on the pad, waiting for upper level winds to fall within bounds for launch. The clock has resumed.
Proceeding with the go-no-go poll for launch. VCON LD mission.
LD VCON.
Confirm flight computer as goes a green.
All as goes green.
Lock auto sequence and confirm.
Auto sequence locked.
All stations where go for auto sequence start at T-minus 2 minutes. At this time, LDs go for launch.
These are on internal power. All stage power is disabled. Vehicle is on internal power.
LOX load complete. System into recirculation.
Stage 1 and Stage 2 tanks are pressed.
Deluge activated.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2.
Plus 30
Stage
seconds
one
into the
propulsion is
mission,
nominal.
Electron is well on its way to space after its 20th liftoff from the pad at Rocket Lab Launch Complex 1. With the
Entered
power
stage
of
one,
those
burn up
Rutherford
detect mode.
engines, with Electron clearing past 700, and very soon Electron will approach max Q, or maximum aerodynamic pressure. And this is the moment when the forces against the launch vehicle are at their peak during ascent. So let's listen in for the
Vehicle
call that
supersonic.
Electron has cleared that
Good
gate.
ship run 1.
Approaching max Q.
HVB discharge nominal.
Max Q cleared.
In about a minute, we'll be coming up to 3 events that happen back-to-back during flight. First is
Guidance
main
is
engine
nominal.
cutoff, or MECO. This is when the 9 Rutherford engines on Electron's booster throttle down before shutting off completely to slow the rocket down before the second event. That's when the first stage separates from the rest of Electron as it continues with the third event, ignition of the sole Rutherford engine that powers Electron and the satellites to orbit. With that stage separation, Electron's booster begins its journey back to Earth, and so will begin our second Electron recovery attempt.
Stage 1 propulsion is nominal and MECO confirmed.
Successful separation.
Stage ignition.
Recovery during the program.
Analyst recovery. Proceed with sequence 59, stage 1 recovery operations.
As you've seen, we've had a successful MECO and stage separation. No, there's been no ignitions. Okay, so it looks like we've had a loss of telemetry.
Preliminary data reviews suggest an engine computer on the second stage detected an issue shortly after second stage engine ignition. That caused the safety shutdown command to be issued, resulting in the rocket and its payload tumbling out of the sky and crashing into the South Pacific Ocean. The running out of tows mission was also Rocket Lab's second attempt to return Electron's first stage back to Earth in a controlled descent. It's part of ongoing efforts to develop a reusable first-stage launch vehicle. But unlike the earlier return to sender mission trial 6 months ago, this time, as Electron's first stage coasted to apogee following MECO, or main engine cutoff, the reaction control system reoriented the first stage 180 degrees, placing it in an optimal angle for re-entry. As well as being equipped with an evolved heat shield designed to protect its 9 Rutherford main engines and direct aerodynamic forces and plasma away from the rocket, this change in positioning also helped the booster survive temperatures of up to 2,400 degrees Celsius as it dropped back down into the thicker atmosphere at up to 8 times the speed of sound. As it reached its descent max Q, or maximum aerodynamic pressure, the first stage repositioned itself engine first, helping it slow down to below Mach 2, at which time a drogue parachute was deployed to increase drag and further stabilize the booster as it descended. Then, the main parachute was deployed during the last couple of kilometers, providing a soft water splashdown. A recovery vessel with a portable strongback was able to retrieve the first stage, which has now been brought back for examination. This is SpaceTime. Still to come, a new nanothin radiation shielding. And later in the science report, a new study shows that RNA from the COVID-19 virus could have found a way to insert itself into the human genome. All that and much more still to come on SpaceTime. Scientists have developed a new ultra-thin nanomaterial that can reflect or transmit light on demand, opening the door to new technologies that could help protect astronauts in space from harmful radiation. The technology could become a key step in ongoing research to shield astronauts on deep space missions beyond the relative safety of low Earth orbit, which subject them to higher levels of radiation and cosmic rays. That remains one of the main barriers on any human mission to Mars. The technology's potential applications include protecting astronauts or satellites with an ultra-thin film, which can be adjusted to reflect dangerous ultraviolet or infrared radiation, significantly increasing the resistance threshold compared to today's technologies, which rely on absorbing radiation with thick filters. A report in the Journal of Advanced Functional Materials claims the product could also be tailored for other light spectrums, including visible wavelengths, which would open up an array of innovations, including architectural and energy-saving applications, controlling the amount of light and heat entering a building by literally turning windows into reflective mirrors on demand. Lead researcher Dr. Mohsin Rahmani from the Australian National University says the material is so thin hundreds of layers could fit on the tip of a needle, and it can be applied to any surface, including spacesuits.
The flat optics is very hot area of research because not only us, many other universities, they are also trying and have done a lot of progress to using ultra-thin surface of nanoparticles, which can actually reproduce the function of different bulky components, optical components like lenses, mirrors, and so on. So what we have done, we have managed to change the optical properties of those nanoparticles so that you can make your nanosurface to have different functions, because all other flat optics and surfaces which I was speaking about before, they work statically. It means they can have one function. They can work and function as a mirror or as a lens or as a prism and so on. But now, because we managed to change the optical properties, we can adjust them to have different functions against different frequencies, and they can have, for example, work as a mirror or as a transparent surface or something in between. And what we do, we just change the temperature of those nanomaterials, and by controlling the temperature, we actually control the function of those nanomaterials. It's how it works.
And this is the sort of material you can weave into a spacesuit.
It's actually, for this particular case, we have used silicon, because we were mostly interested in the telecommunication wavelengths, and for that range, silicon is a perfect material. But if you want them to work against different wavelengths, different radiation, and different frequencies, you need another design, and you need to use other materials. For example, if you want to come to the visible range, you need to use maybe aluminum arsenide or gallium phosphide. If you want to go to the near infrared range, you can use silicon, and so on. You can cover this function, and you can cover this capability from ultraviolet to mid infrared by having different designs and different materials.
What happens in the ionizing radiation end of the spectrum, which is where one of the big problems we're going to have in space, especially with long-distance missions to Mars and things like that, is the ability to protect crew from ionizing radiation, as well as cosmic rays, things like that.
Sure. We believe that we have already developed the physics for it, and because the physics actually it works in the different frequencies, and you need to have different designs to work at a different range, like what you mentioned, maybe probably smaller than the wavelength is smaller than ultraviolet light, like X-rays and so on. So the physics is the same. But the point is that at the moment we need probably to wait a little bit more to get the technology to fabricate smaller structures, because at the moment what we can cover the ultraviolet to infrared easily, but in order to go to the smaller wavelengths like X-rays, you just need to have smaller structures whose dimensions are in the order of those wavelengths. Means that I'm speaking about the molecular level, which are still smaller than what we have fabricated. But I believe that very soon we will get there. We will get there because the physics is available. As soon as we can just manage to fabricate those small particles, we can solve this issue.
So right now it's just a question of getting the nanotechnology right, and until we do that, then we're still looking at huge water tanks on the sides of spaceships to act as radiation barriers for trips to Mars, things like that.
At the moment, I have to say that, but I can for sure say that we are not really very far from that level.
Oh, wow.
To use nanotechnology to protect all these devices, satellites, and space aviation against different kind of radiation. The physics is available, and we are working on that, and we believe that we have a solution for that, but it's still not published. We are working on that, but I can tell you that we are not really far from that. We are all working on these photonic nano devices for different kind of applications. But for this particular piece of research, we are working around 2 years to make it work.
So tell me about the applications you see for this.
The applications which are doable right now, which are feasible right now, of course, you need with a little bit of investment, is to have them, to fabricate this nanostructure. You can fabricate them on any kind of surface. You can fabricate on your house windows. You can fabricate on your car windows, and you can actually turn any window to mirror and vice versa on demand, because you just need to control the temperature of those nanoparticles, and what we will achieve at the end is just on your hands, and at will you can change the function of your window. It can have some application in the architecture. For example, in the bathroom, your window, as we mentioned in the video, in the bathroom, your window can become a mirror, or even in the windows of houses, if you have this thin layer of nanostructures, you can control the amount of light which goes into your house in different seasons, which is very important for energy saving actually, and applications in this sort, which are applications which are doable at the moment. We are speaking with a few industrial partners. If we get a decent investment, which we are very hopeful and we are very optimistic to get it, because we got large interest from the industry, I believe that in maybe just 2-3 years we can see the first prototype of this kind of windows.
As well as protecting from heat and things like that, these surfaces will also provide opacity, so you can have privacy as well. Right now there are devices which do that, but they work separately from devices which protect from heat.
Yes, actually, it is that at the moment we have some devices which can we can make the glass opaque.
Yeah.
It's based on the liquid crystal which is already available, but it is the first time actually which you can make a glass window, and the importance here is that when you a mirror. A glass mirror. When you make a glass mirror, actually it reflects all different radiations. It doesn't absorb it. But when, for example, by liquid crystal you make it opaque, it just absorbs all those radiations. It makes a big difference in the threshold, because when you observe, of course, you can observe until certain threshold. But when you reflect all those radiation which you don't want, you have a lot of more room and a lot of more threshold, because you don't observe it and you just get rid of it. So it is the difference which our research can bring.
How far down the track are we from being able to use these materials for spaceflight, for human spaceflight?
At the moment, we believe that they are still usable around the world, because as you know, until a few radi of the Earth, we still have this magnetic field of Earth. That's why, because of this magnetic field, still we don't have much radiation in the X-ray and gamma and so on. Still, the problem around our Earth is the UV and near-infrared. So at the moment, this research can be used in the space station and all the areas around the world, because still we are within the shield of magnetic field of the Earth.
Yeah.
But when we go further, and like what you mentioned, to the Mars, you still need to wait a little bit more, but I believe that it's not so long, to have these nanostructures to protect against all kind of harmful radiation.
When you say all kinds, can nanostructures be useful against things like gamma rays and high energy X-rays?
We believe so. At the moment we are working on that. It's very exciting, because we have found a way to do that by making some nanostructures. I can say that by some kind of new physics, you can make the nanostructures to even work at maybe X-ray and gamma.
That's very exciting.
We are very excited, because our technology which we published, it's just at the moment it goes to UV, but in order to gamma and X-ray you need some more physics. We are hoping that we can make it happen.
That's Dr. Mohsin Rahmani from the Australian National University. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study warns that RNA from the COVID-19 virus could have found a way to insert itself into the human genome. The concern centers around the prevalence of people testing positive for COVID-19 in PCR tests, despite having long cleared the active infection. Retroviruses, like HIV, do this through reverse transcription, the enzyme-mediated synthesis of a DNA molecule from an RNA template. But COVID-19 isn't a retrovirus, so it could be using some other mechanism to achieve the same result. A report in the journal The Proceedings of the National Academy of Sciences claims researchers believe the mechanism could be a specific type of transposon, a small sequence or segment of chromosome that can undergo transposition, jumping from one place to another. These so-called jumping genes are often found in bacteria, moving segments of DNA from one place on the genome to another. Humans also have transposons, and the authors focused on line 1 transposons, which make up a significant 17% of the human genome. The authors then tested their hypothesis by successfully inducing COVID-19 into human cell lines in laboratory tests. However, in 30% of cases, they couldn't confirm that this was indeed the mechanism taking place. So, while they showed that it might be possible, they couldn't show that this is in fact what's happening. Over 3.5 million people have now been killed by the COVID-19 virus, with another 166 million infected since the deadly disease first emerged in Wuhan, China, and was spread around the world. A new study has concluded that the huge extent and severity of the devastating 2019-2020 Australian Black Summer bushfires was most likely the result of unprecedented drought conditions and sustained hot, windy weather during the fire season, rather than the logging history of the native eucalypt forests. The findings, reported in the journal Nature, looked at 3 regions covering around a third of the total area burnt. Scientists found that past logging activity and wildfire disturbance in the natural forests had a very low effect on severe canopy damage. Instead, the most important factors were broad spatial features of the landscape, such as ridges and valleys, and fire weather. The study also found that 70% of the New South Wales timber plantations suffered severe canopy damage, showing that this intensive means of wood production is extremely vulnerable to bushfire. The authors say that in the future, fuel loads are likely to become less important than climate drivers in determining fire extent and severity, making it increasingly difficult, if not impossible, to lower fuel loads in a way that will limit the severity of bushfires. The Black Summer bushfires burnt at over 186,000 square kilometres of landscape, killing more than 3 billion terrestrial vertebrate animals, including many highly endangered species, some of whom were driven to extinction. The massive wildfires also destroyed almost 6,000 buildings, including 2,779 homes, killing at least 34 people. Paleontologists have identified a new species of hadrosaur dinosaur in 72-million-year-old strata in northern Mexico. A report in the journal Cretaceous Research says Laetolosis gallorum was a herbivore about 12 metres long. Scientists have unearthed about 6 metres of fossilized tail, as well as a femur, a shoulder, most of the skull, and a 1.32-metre bony hollow crest, which is thought to have been used to communicate, creating a sound something like a trumpeting elephant. A new study warns that requirements for increasingly complex website passwords are leaving users frustrated and can lead to poor password security. Researchers from James Cook University found website password requirement restrictions, such as needing at least 8 characters with a mixture of upper and lower case, as well as numbers and other symbols, makes passwords harder to remember. And that's led up to 75% of participants using strategies to remember their passwords which actually compromise security, such as using the same password for multiple sites. While measures such as password managers and two-factor authentication protocols do offer solutions to password management and securing privacy, they still suffer from usability issues and demonstrate inconvenience to users. The authors say a better idea would be creating a long but meaningful password phrase that's easy for users to remember, but long enough to hinder brute force hacking attacks. A survey of 1,000 people has found that 48% of Australians, it's roughly half, believe in ghosts, or at least the possibility that ghosts could exist, while 69% of people believe in a soul. Tim Mendham from Australian Skeptics says the survey also shows that younger people are stronger believers than the old, and women are much stronger believers than men.
There's a group called the McCrindle Research for the Centre for Public Christianity. So it's a Christian group, and they surveyed 1,000 people and asked them for their views on ghosts and miracles and angels and a lot of spiritual stuff and, of course, God, etc. And it came up with a lot of numbers that were particularly pro a lot of these spiritualist things by comparison. For instance, 48% of Australians say they believe in ghosts or the possibility that ghosts exist. 69% say that the soul exists. And that might be a bit high compared to what you normally think of as the breakdown of this Australian population. The largest single group within the census on the religion question is always no religion. Not always, it has been for a while, no religion. And considering the numbers there, I'd be surprised if 69% of Australians believed in the soul, but similar sort of numbers believing in angels and that sort of stuff. The ghost is the strongest belief group apart from the soul.
You really got to pack all those together, don't you? Ghosts, souls, angels. Because we're really talking about the same sort of thing here. It's some sort of...
To a certain, I mean, there's a lot of ghosts I sort of almost put in a separate category. There's spirits and there's, appearances of people, but in many cases, the ghost stories don't have a link with any religion as such. Because, I mean, the ghost stories that you hear about, I've seen a ghost, don't necessarily have a link with religion. The religions might have ghostly elements in them, but that one is a bit different. But miracles, angels, God, soul, the meaning of life and life after death generally have a link to religion. This survey being done by a religious group, they supposedly had an independent 1,000 people they interviewed, but what they did find out was the strongest belief actually came from people who are 18 to 26. Which
I found that interesting. 18 to 26-year-olds were the most likely to be religious. Females more than males as well.
Females more than males is actually pretty common across all age groups, and if you can figure that one out, that's a $64 million question as to exactly why.
Older people and males are more sceptical.
Older people and males are more sceptical, yes. But the question as to why there is this gender breakdown, in some cases it's pretty minor, but in other cases it's quite significant. And if you figure out the reason for that, there are obviously people who put forward suggestions, but I think it's a very complicated issue. But the fact that young people supposedly believe in these things more than older people, perhaps that's because older people have a lot more experience, I don't know. This survey said that the younger people had a greater openness to the non-material. I think that might be wishful thinking, although if you look at the number of young people following charismatic religions, the Pentecostal and that sort of stuff, they're very in favour of miracles and angels and ghosts, taking all that sort of stuff very literally. That's where they're going, that the established church, which are more restrained, to a certain extent, are not as attractive to these more outgoing whoopie-doo rock band inspired churches, etc. And so they're falling for that thing. It's a funny one. There are some doubts expressed about the survey itself and the fact that it came from a religious group rather than an independent source.
1,000 people isn't really a decent survey size either.
It's not a huge one. It's not bad, right? I mean, there was certainly a lot worse, but yes, it's not huge. And you wonder, there's not a great indication as to where the 1,000 were drawn from. It's supposed to be reasonable in polling terms, that it's not an online you write in and you tell me sort of thing, which is normally rubbish, but it's an interesting result, but I'd like to see a lot more in-depth analysis of it.
Most political surveys have at least 2,000 people interviewed.
Yes, I mean, as I say, you don't know exactly where this 1,000 came from. Most political surveys tend to also drag, unless they're looking at a specific electorate, they tend to draw them across a wider geographical area. But that means you're going to ending up with a small number in each particular electorate. So, the lower the number, the worse or the more unreliable the poll results are. You'd really want tens of thousands if you could.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.